In this video, we vary the wavelength of sine function using Maclaurin series and Taylor series for the values of W from 6 to 12. So data validation, list of items, 6 to 12. You can start with 6. Now the Maclaurin series, which is sine of W is equal to the summation of A times x to the power 2n plus 1, where the value of that is x to the power 2n plus 1, and the value of A is minus 1 raised to the power n times W raised to the power 2n plus 1 over factorial 2n plus 1. So n starts from 0 to infinity. 20 is good enough. And the value of A, array formula, minus 1 raised to the power n times, that's W raised to the power n, so W raised to the power, so raised to the power 2n plus 1, the quantity 2 times n plus 1. We have completed the numerator. Now the denominator, factorial 2n plus 1. Now we can continue with the summation, which is array formula, series sum. So this is the Maclaurin series of the x values raised to the power 2n plus 1, where 2n plus 1 starts from 1 incremented by 2, and the coefficient will be this range. Now we continue with the Taylor series. We have just completed the Maclaurin series, now the Taylor series, which is sine of x raised to the power w times b cotangent of x raised to the power n, where the value of b is combination w comma n times sine wn minus w minus n times pi over 2. So our n is from 0 to w, so n is from 0 to w. So this will be array formula, combination w comma n. So that's the first part, the combination. Next is the sine function. So that's sine w minus n times pi over 2. So this is sine 0.5 pi. That's the first part, times the quantity w minus n. We close the sine function, and we close the array formula. Because n is from 0 to w, we have an error, so we correct this. So if n is greater than w, if n is greater than w, then it's 0. Otherwise, calculate. Now it's corrected. Now we continue with the Taylor series. We can complete the Taylor series, which is the summation of b cotangent of x raised to the power n. So this is array formula, cotangent of x raised to the power n, where n starts from 0 incremented by 1. So this will be series sum. Series sum. I forgot the series sum. So series sum cotangent x raised, and the coefficient will be this range. That's the coefficient b. So the summation of cotangent x raised to the power n is series sum cotangent x raised to the power n starts from 0 incremented by 1, and the coefficient b will be this range. And we continue because there's one more, sine of x raised to the power w. So we multiply this. Sine of x raised to the power w. Let's go over this. We have an error. So if x is 0, it should be 0 because it's a sine. So if x is equal to 0, it should be 0. Otherwise, calculate. Now it's corrected. Now we can chart this. Insert chart. And we use scatter chart. We don't need the title. To go back, use column as label. And then show the trend line. The type of the trend line, polynomial. The degree of the trend line, 10th degree. And because we deleted the title, we use the equation as label. So here's the trend line. And the polynomial to the 10th degree. We can increase this to 10th degree. So that's how it looks. Suppose we change the value of W to 8. We shorten the wavelength. We also shorten the wavelength of the Taylor series. Shorten the wavelength of the Maclaurin series. Now it's shorter. We also shorten the wavelength of the Taylor series. They're the same. Shorten the wavelength of the Maclaurin series. It's shorter. Shorten the wavelength of the Taylor series. So this completes the comparison of Taylor series and Maclaurin series using the varying wavelengths of sine function and the functions COMBIN, sine, cotangent, array formula, data validation.